Welcome to Maths and Science by IITian channel. In this lecture for JEE and NEET physics and CBSE physics or CSIR, I will be continuing with the thermodynamics in physics, and in thermodynamics I have already released one lecture on thermal properties of matter. We will be continuing with the thermal properties of matter, and we will take up temperature in this lecture. In temperature, we will define the temperatures and we will try to know the equipment being used for measuring the temperature, which are called as thermometers. There are various types of thermometers available. Thermocouple, constant volume gas thermometer, constant pressure gas thermometer, electrical resistance thermometer, and also liquid thermometers. We will study them one by one and we will briefly know about what are these, what is thermocouple, and before that we will continue with the thermal properties of matter. In this mainly we will be discussing about temperature and thermometers, but before that we will continue with the other thermal properties. The other thermal properties we will continue. One, thermal properties continued. Till now what we have studied? Pressure, volume, temperature, and also what we have studied is specific heat capacity. Now, there is another property called property of the system. In specific heat capacity, specific means per kg. Anything divided by mass. It's a general idea. It's not what you call a rule. I'll just tell about the general idea. If you are asked to find out specific volume, let us say. What is specific volume? What is this term specific is added to here? What is specific volume and what are the units of specific volume? We know density. What is density? Density is kg per cubic meter. Now, what is the reverse of the reciprocal of density? What is the reciprocal of density? Reciprocal of density specific volume. Please try to relate these two. Density is rho kg per cubic meter. whereas specific volume is equal to cubic meter per kg. That is equal to 1 by rho. This is represented by small v. This is another thermal property you should know. Density, you know, reciprocal of density is a specific volume. As a thumb rule, don't take it, it's 100% valid in all cases. As a thumb rule, we can say, as a thumb rule, specific means per kg. As a thumb rule, only, it is a shortcut. Whenever something is given, then specific heat is given, that means per kg. Not valid always, but it is valid at least more number of times as far as you are concerned. Like specific heat is heat per kg. Then what is specific volume? Volume per kg, that is cubic meter per kg, that is 1 by kg per cubic meter, that is equal to 1 by rho. That means V is equal to 1 by rho density. This you keep in mind. Specific energy, energy per kg. Specific volume, volume per kg. Specific enthalpy, enthalpy is heat energy as far as volumes are concerned. This what you call units are concerned. Let's not go deep into enthalpy. We will study when time comes in detail. Enthalpy or specific enthalpy. The units of specific enthalpy are, this is also property of the system, that is joules per kg. It can be kilojoules per kg also. Specific means per kg. That you can safely apply this rule, but not always. Entropy is also a measure of heat energy only. Entropy, measure of heat energy only, that is measured in joules per kg. Specific internal energy, I am just giving you additional examples on specific. It is specific entropy, let us say. Specific internal energy. You know, internal energy is the internal energy of the body, that is measured in joules. That is also joules per kg. And heat capacities we have already seen. Then can we use some specific here? It's not a property of a substance. No, it is a property of a substance. It is a property of a substance. Specific heat of a substance is heat capacity divided by kg. It is of two types. One is at constant volume, two at constant pressure. This is called as CV, small cv. Constant pressure is small cp. Small cv is equal to joules per kg Kelvin. Cp at constant pressure. This is measured at constant pressure and constant volume, Cp and Cv. These are the different possible thermal properties we come across while dealing with thermodynamics. If you can understand these and definitions, if you know, specific heat is a property of the matter. It is a property. If it is told that it's not a property, that's not correct. It's a specific, it is a property of the matter. Now, we'll go for temperature. Now, in thermodynamics, because until unless we go on adding the definitions and we go on discussing the units as we come across, we will be doing it definitely, and we have to go a little bit fast as far as definitions and measurements of these properties are concerned, and we will little bit move faster. Now, what is temperature? There are many ways of measuring the temperature. Temperature is the field with reference to some reference frame. Physics is full of References. Temperature is the measure to find the hotness and coldness of the body, of the matter. This hotness and coldness, how it is defined? It is defined with reference to something. It is also directly or indirectly connected to the kinetic energy of the body. It is a relative measure. Something is cold, something is hot. That means with some reference, we are measuring this particular property, hotness and coldness of the body. And this can be measured by using many instruments or equipment such as thermocouples, constant volume gas thermometer, constant pressure gas thermometer, electric resistance thermometers, and also liquid glass thermometers. Mercury is a liquid. Liquid glass thermometers, you are well aware how to use them. Whenever there is a fever, doctor comes and puts that thermometer in your mouth and he sees what is the temperature you are having. That is a reference. Hence, he will tell whether you have the fever or not. That is liquid glass thermometer. There are gaseous thermometers also which use gas as the medium to measure the temperature. And constant pressure, constant volume, electric resistance, thermocouples. Now, you have got the instrument and you have understood the temperature which measures the coldness and hotness of a particular body or matter, and you may be having a thermometer which shows a temperature of, your fever shown a temperature of 100 degree. What is that 100 degree fever? That 100 degree fever is measured in Fahrenheit. In regular our thermometers which we use for fever. That means depending upon the use, we use particular type of thermometer. We cannot use this Fahrenheit thermometer in furnaces where temperatures will be in thousands, 2000 degrees centigrade. That means we will be using some other type of thermometer. The small Fahrenheit thermometer with some particular range also, because we can't have a range of 0 Fahrenheit to 2000 degree Fahrenheit for measuring a temperature of a human being. That means the scale of the temperature, the scale, the size and the units, they are very important. Even in furnaces also we can go for temperature in Fahrenheit, but however it is better to use in degrees Kelvin and degree centigrade. Degree Kelvin is the SI unit of temperature. It is widely used and it is accepted in scientific and engineering measurements. It is an SI unit. SI unit is Kelvin. Kelvin, you please remember, this is a capital letter. kg is different. It is a K, small k here. Whereas in Kelvin, it is capital K. Kilo, small k, is equal to kilo. But capital K means Kelvin. Both have the same letter, but Small k is kilo, capital K is equal to Kelvin. This is Kelvin. This is for temperature. This is for kilo measurement. Kilogram, kiloliter. That's up to you, whatever you want to measure. Now, this is SI unit, Kelvin, and there are different types of thermometer scales are there, temperature scales. Temperature scales, what are the scales of temperature? One is degree centigrade, degree Fahrenheit, Kelvin, capital K, and also Rnakine and Reameur. Rnakine scale, Reameur scale. Out of these, we regularly use degree centigrade, degree Fahrenheit, and degree Kelvin. These are most widely used, whereas Rnakine and Reameur for specific purpose. Now, if something is there, because I have already told in from many classes I have been telling you, physics always involves a reference frame. For example, my reference frame is this. This is the reference frame. And I have different, this is a reference frame. I have different measurements like this. I can say below the reference frame also something is there. Now, let me say my reference frame, I take degree centigrade as my reference frame. First reference, degree centigrade, that is ice point of water. Let me say my first reference is ice point of water. It is degree centigrade, let me say. What is the ice point? 0. Next is boiling point of water. Second is boiling point of water. This I am just only doing the reference, that's all. Don't worry. Boiling point of water, what is its value? It will be 100. Correct? Then, this is degree centigrade. This is, let me say, this one is degree Fahrenheit. And this one, let me say, it is Kelvin. The boiling point, the ice point of water 0 degree and ice point of water in Fahrenheit will be 32. Are you able to follow me? Please. Let us remove this because we have taken ice point. The ice point started here. Boiling point is 212. These are the standard values we measured with different equipment. We will talk about the equipment afterwards. Now, what is next? When you do it from the reference point, and this is 273 Kelvin. That is ice point. These are all ice points. Here it is 373 boiling point. These are boiling points. Okay. Now, when you do it in degree centigrade, ice point and boiling point. Let us write. It is 0, it is 100. In Fahrenheit, it is 32, it is 212. In Kelvin, it is 273 and 373. In Rankine, let us say, we can use Rankine also, that's up to us. Reameur also we can use for the sake of what you call understanding. You write as a homework, find and write ice points and boiling points in Rankine scale Rankine scale and Reameur scale. Now, we know this. What is the difference between the ice point and boiling point? In degree centigrade, it is 100. In degree Fahrenheit, 212 minus 32 is 180. In Kelvin, it is not degree Kelvin. It should be Kelvin only. There is no degree for Kelvin. Kelvin is 100 now. The temperature scales comparison can be written like this. Usually, it can be written as, how do you write? Some temperature, we'll call this as Tc. We'll call this temperature as Fahrenheit. We'll call this temperature as, let us say, Tk. There is nothing wrong. Tf minus initial point divided by total difference is equal to Tc minus initial point divided by total difference is equal to Tk minus 273 initial point divided by difference. This is how we convert, and instead of these scales, if any other scale is also given, how to do it, I will tell you. The general formula is T in any x units divided by T initial or ice point, let us say. T ice divided by T boiling minus T ice. Is equal to any other scale, Ty minus T ice in that divided by T boiling in x scale, T ice in x scale, T ice in x scale, Tx. Here another scale, Ty minus T ice in y scale, T boiling in y scale minus T ice in y scale. You are able to understand? This formula, if you have, whatever the scale is given in the examination and asked to convert from one scale to another scale, without knowing its name also, you can easily convert. I will again write for your convenience. Please, this is very important. Tx is to be found out, which is to be found out. T ice in x scale minus T boiling in x scale minus T boiling in T ice in x scale is equal to Ty minus T ice in y scale divided by T boiling in y scale minus T ice in y scale. It looks simple, but however, please remember this. From this, you find out for Reameur scale and also Rankine scale. Okay. You can find the relation between degree centigrade scale to Rankine scale, centigrade scale to Reameur scale to Kelvin. That means all these things we can do. That is how a temperature is calculated and measurement of temperature. Now, the main important, we have got the scales with us. We know what is temperature to measure the hotness and coldness with reference to something. And we have the scales. Now, measurement of temperature is required to be studied. Measurement. Any physical quantity measurement, it requires an equipment. How can you measure something if you don't have the proper equipment with you? To measure the physical quantity, we require an equipment. And what are the different types of equipment available for measuring measuring the temperature? It is done by thermometers. What are the different types of thermometers? One is thermocouple. Another is constant volume gas thermometer. It's a gas thermometer at constant volume. Because for an ideal gas, PV is equal to nRT. Temperature changes with pressure and also temperature changes with volume. PV is equal to nRT. If N and R are constants, PV is directly proportional to T. Pressure and volume both have influence on temperature. Hence, sometimes we have to keep the volume constant and sometimes we may have to keep the pressure constant depending upon the working conditions where temperature is to be measured. For example, I cannot increase the pressure in a particular equipment, but still I want volume is increased, but still I want to measure the variation in temperature. That means I will keep the pressure constant. In the factory, in certain conditions, we may have to keep the conditions where volume can be constant or pressure can be constant. Constant pressure gas thermometer. Now, sometimes we cannot use both. We may require electric resistance. What resistance takes place? In electrical resistance, it is the resistance. Whenever electrical current passes through the wire with resistance, the resistance gets heated. It gets heated. That means temperature is nothing but the measurement of relative measurement of coldness and hotness. When it becomes hot, that is I square R. This type of temperature measurement equipment are also there. They use this principle, resistance and electricity. Now, electric resistance measurement, thermometers. Now, another is fifth one, most important and most widely used, liquid glass. Liquid glass thermometer. Now, let us briefly discuss one by one the principle of, from the name itself we can easily understand, from the name itself we can understand what is it, what each is, but however we'll just have some little few minutes discussion on each. Let us try to have. Now, first one is thermocouple. You come across this thermocouple. What is the meaning of couple? Couple is nothing but jointing. Coupling is jointing. That means thermocouple means two types of material getting jointed, having different thermal properties. Because it is used for the measurement of temperature, we can say it is coupling of two different wires, two different materials or metals, or two different wires. They are coupled at a junction where temperature is to be measured. Because, for example, there is one wire, it is copper wire, and it is the junction where your temperature is to be measured, and this is constant. This is one material, material 2, and this is another material having different thermal properties. These materials, when they are connected, this is having a resistance of R1, let us say. It has the resistance of R2. When current passes through it, what happens? It is a circuit we made, something of this. Let us say, I am only simplifying. It may be a little bit more complicated than this, but I am only simplifying and telling you. And at this junction, there will be a change of resistance. Resistance of copper is different, resistance of constant pipe line is wire is different. Then there will be a change in the hotness and coldness. Change in, again it is hotness and coldness are relative, hotness or coldness, because of change in resistance or change in the message. This is measured and here EMF is measured. EMF is directly proportional to V is equal to IR. EMF is nothing but electromotive force, that is EMF. If you see in overall sense, in voltage, EMF is directly proportional to And resistance, we have already seen, resistance is directly proportional to hotness and coldness. That means T hot minus T cold. Are you able to understand? This is the principle used in this thermocouple. Thermocouple is a very simple thing. It is a connection of two dissimilar materials having different resistances, and when an EMF is induced, that EMF is directly proportional to T hot minus T cold. EMF produced or EMF induced. You induce something and EMF produced is T hot minus T cold in this circuit. Now, it is called as Seebeck effect. Please remember this. When two dissimilar materials are connected at a junction, the EMF produced in the circuit is the measurement of difference between hot and cold temperatures. We can have different types of dissimilar materials. As I told you, copper constant, and when we use it, the temperature range. Depending upon the temperature range you require and the measurement of temperature, then this thermocouple is used. There is no external power required in it. This is the principle of thermocouple. Now, what is next? Constant volume gas thermometer. Second one is constant volume gas thermometer. Name itself says we keep volume as constant when volume is constant. PV is directly proportional to T implies P is directly proportional to T, where T is the capital T, that is in Kelvin. Then the temperature T is equal to constant pressure, constant volume. TCV is equal to 273 into pressure at which you are measuring the temperature. divided by pressure at a particular temperature, you know. This is the formula. Similar is the case with constant pressure gas thermometer. In this, TCP, constant pressure at which you want the temperature, is 273 into volume at which temperature is required divided by volume at which temperature is measured. You know the value. Now, thermocouple is discussed, volume gas thermometer is discussed. Fourth one is electric resistance. Don't worry, we will do one or two. The similar way we can write T at a resistance where temperature is required is 273 into resistance at which temperature resistance applied and resistance of known temperature. We'll do one or two numericals on temperature scales, so that in the next class numericals on temperature scale, so that you will understand how you can apply them in various conditions. Let it be constant volume gas thermometer, constant pressure gas thermometer, or liquid glass thermometer, or electric resistance thermometer, or a thermocouple. Now, last and final is liquid glass thermometer. The principle is the liquid level. The temperature at some liquid level is equal to 273 into liquid level at which temperature is to be known and liquid level of some particular temperature known. In the next class, we will be doing some numericals on temperature scales, because these are very important before going into the real chapter of thermodynamics. Once you are confident and you know these things, then I can go faster in thermodynamics lectures. With this, I wanted to conclude this lecture, and in the next class we will be taking some numericals. And best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. And if you feel there is a value addition because of this lecture to you, kindly share this video and subscribe to my channel Maths and Science by IITian. And kindly hype my lecture video. Thank you. Best of luck.